Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 3 for this week, and we're going to be talking about temperatures and gases and volumes and all sorts of stuff. But the thing that inspired this, when I was thinking about what I was going to do this on, is that when I got to college, I really didn't know what the definition of temperature was. I knew that as the temperature was higher, it felt hotter, and lower, it felt colder, but didn't actually know the scientific definition of it. So we're going to start with that and then get into something called the ideal gas law and all that that implies. So here we go, and the definition of temperature is this. It represents molecular kinetic energy. Kinetic energy is simply movement, okay? So it's how fast the molecules and or the atoms are actually moving, okay? In other words, again, how fast they're moving. Now, the faster the movement, the higher the temperature, okay? So at a high temperature, those molecules and atoms are going to be moving fast, and at a low temperature, they're not going to be moving nearly as fast. And at absolute zero, which is 0 degrees Kelvin, minus 273 degrees Celsius, or minus 459 degrees Fahrenheit, then all molecular motion ceases, okay? Basically, everything is dead at that point. Thankfully, we don't get down to that temperature. But the higher the temperature, the faster those things are moving, and the lower the temperature, the slower they are moving. So then there's this thing called the ideal gas law, which states that the pressure times the volume is equal to the number of moles, and I'll get to that in a second, times a gas constant R times the temperature, okay? Now, what is pressure? It is the net force per unit area, okay? Area is 2 dimensions, volume is 3 dimensions, so net area would be like a square. And it's the net force per unit area perpendicular to that surface. So if you have a surface like this, then it would be the net force going right at that surface, 90-degree angle to it, perpendicular to that surface, exerted by the molecules rebounding from it, okay? So the molecules are zipping along, they hit that surface at a 90-degree angle, they bounce back, and the number of molecules hitting that area at a 90-degree angle is basically what pressure is. Okay, and then what is volume? Well, that's the amount of space that an object occupies, or a gas, okay? So recapping all of this, there's the law. P is pressure, V is volume, N is the number of moles, R is the gas constant, and T is the temperature. Now, it turns out that 1 mole of a gas is equal to 6.02 times 10 to the 23rd particles, if you will. So that means if you take the number 6.02, then you make sure you have 23 digits to the right of the decimal point, okay? So you would have 0 and 2 and then 21 more zeros, okay? It's a ton of particles, all right? And that's just 1 mole of a gas, okay? So there's your equation again. So what can we derive from this? 3 interesting things. At a constant pressure, volume is going to increase with temperature. So you have the same amount of molecules bouncing off this surface, this 90-degree area. And so with the pressure being the same, as the temperature increases on this side of the equation, if this is constant, then the V has to go up as well. So as the temperature goes up, then that gas is actually going to expand, okay, and take up more space, okay? So volume increases with temperature. Now, at a constant volume, okay, so the amount of area that this object takes up, then the pressure is going to increase with the temperature, because again, if this is constant and this is going up, then this has to go up too if these two aren't changing, okay? So at a constant volume, so you have the same basic box, if you will, then as the temperature goes up, the pressure is going to go up because you're going to have faster moving molecules that are going to be bouncing off that surface really, really fast, and so those two are going to be in sync. However, at a constant temperature, okay, then pressure is inversely proportional to the volume of a gas, okay? So if the pressure goes up, okay, if this is the same and this is the same and this is the same, then if this goes up, this has to go down. And if this goes up, this has to go down, okay? So the number of molecules that are bouncing off that surface, if that increases, then the volume is going to decrease and vice versa, okay? So those are three things, three basic principles that you can derive from that ideal gas law, PV equals nRT, okay? All right, that is bonus weather video number 3 for this week. I hope that made a little bit of sense. Next bonus video Monday, next daily update Monday, although I will be giving you text updates and image updates over the weekend about the tropical system that should at least become Tropical Storm Debbie sometime over the weekend. All right, folks, you all take care. Have a wonderful Friday evening, what's left of it, an even better weekend, and we'll talk to you Monday. See ya.